speed u at an angle theta. Let's say somewhere here the velocity vector is like this. Then how the gravity is going to act vertically down. Now this gravity, a part of, and this will make an angle theta. Not visible. Some phi, I'll take it. So if you can resolve this now, if this is phi, this should be phi. Now if you resolve this, the g, you can resolve g cos phi and g sin phi. The velocity vector is directed in this way. If I resolve this, here g parallel will come in this direction. Other g perpendicular will be in this direction. I'll introduce many other concepts. Let me first go for that in this one. This g parallel is called as a tangential acceleration. So we just call this as a parallel. Let this be like a perpendicular. So why a parallel should be called as tangential acceleration? Yeah, Vishal, I'll check it. I don't have answer. No, this will be. No, this anything if you draw it, say this is a path, no? This is a path of the projectile. Path of projectile. And you are going to draw a tangent to it. And any acceleration directed along the tangent, you should call that as tangential acceleration. And this will become a normal. So we'll extend this. This will be called as normal. This is called a tangential. Or this is the tangent. So an acceleration directed along the tangent to the path is called as tangential acceleration. An acceleration directed normal to the path is called as a normal acceleration. That normal are indicating by symbol a perpendicular, tangential by a parallel. So this now, so we have a g now. So can we resolve now? G sin phi. So what is a parallel? A parallel is equal to, in fact, g sin phi. But we don't know phi. Phi is what we assumed it. Okay, let's do one thing. Horizontal velocity, horizontal component of velocity must remain constant. So u cos theta should be equal to v cos phi. Further, what is v? Speed of the object at that particular position. This also assumed it, no? Find out the tangential acceleration of the particle after time t. So this v sin phi should be equal to u sin theta minus gt. What is our question? A parallel is needed. And the phi I should bring in terms of theta. Okay, further what I do is like this v I'll substitute there. U cos theta by, or squaring and adding something, whatever you wish, you can do that one. Altogether, theta and t. Maximum will tie to this. Answer should not be there in terms of v and phi, at least, because these are things assumed. So this v and cos phi should be eliminated. This phi should come in terms of theta. That's what we should try to work out here. Okay, after some time t, this will be the velocity vector. So now if I substitute this value of v here, so this will become u cos theta by cos phi. So this will become, substituting that here, u cos theta cos phi sin phi u sin theta minus gt. So this will become u cos theta tan phi equal to u sin theta minus gt. So tan phi is there. So this will become tan theta minus gt by u cos theta. We wanted only sin phi. Here I got expression for tan phi. I think with the help of tan phi we can easily replace the sin phi. Or else you can do one thing. Anyway, you're going to get this one. This sin phi is there, no? Sin phi you can write u sin theta minus gt here. Then replace v by that. Solve it. Either of one. Okay, have this also, like, you know, because at many places needed. So we'll do by other method. Sin phi what you can write u sin theta minus gt by v. Further v what you can write this one. So we'll solve for sin phi. We'll get the required answer. Let me express in other way. So this, let me keep it here. Let's go for this one. So this sin phi I can also write as u sin theta minus gt by v. What is v is equal to? U cos theta by cos phi. Again, cos phi is unknown, no? So unknown thing in terms of known thing should not be brought here. Are you getting this one? You can't just replace sin phi. Actually, tan phi is what a suitable thing. From tan phi you should bring sin phi. What is the tan phi? Opposite by adjacent. So you adjust this one, tan theta, u cos theta. I think sin theta it will come. So from tan phi you have to bring the sin phi. Vishal, g by tan theta tangential acceleration is asking. So this is again I'll take it out, not beneficial. I think that this is what let's try to do here. Anybody? Tan phi is there. Further what we can do? Tan phi equal to u sin theta minus gt by u cos theta. Dividing these two equations, instead of all this, divide these two equations, get. But somewhere this also needed for us. Find after what time the angle made by velocity vector with horizontal will become this much. Okay, this formula is very useful for us. That's why I just wanted to derive. I kept it here. So yeah, now sin phi what you can write it as from tan phi. This is equal to u sin theta minus gt by u cos theta. Okay, this is okay. Call this is say some quantity here, under root this will come. Now from here bring the sin phi, substitute here. You'll get the tangential acceleration. So this will be equal to how much then? U sin theta minus gt whole square plus u cos theta whole square. Sin phi will be let me simplify. This will become u square under root of u square plus gt square minus 2u g square t square. Substitute the sin phi there, we'll get the required thing. So a parallel equal to g sin phi, g into I'll bring this equation. Not possible. Will it be constant tangential acceleration? No, it will vary with the time. No, that's why the function of time it has to come. This will become tangential acceleration. Complete problem description is there. There's one formula, please do remember. At many places it will help us a lot.
Excuse me, sir.
Yeah.
Sir, could you please tell what is tan phi in that formula which you have written, sir?
This one, where?
Which you have marked it with yellow, sir.
Tan phi equal tan theta minus gt by u cos theta. Are you
What
able
is
to?
5 in it, sir? 5.
Huh?
What is 5, sir, in it?
Phi is a here. Are you not looking at here? Angle made by velocity vector with horizontal at any time t.
Okay, sir.
Here phi is available, no? Here I did marking. Sir, like, are you sure you are correct? Okay, we know at half of the at highest point, how g will be always acting vertical. So at highest point, what is the tangential acceleration? Will be 0. Substitute here, t equal to u by u sin theta by g. In fact, we'll get 0. Okay, agreed. At highest point, so what will be the tangential acceleration? Will be 0 here because there won't be any acceleration acting here. We'll discuss radius of curvature also because almost all the data is there, or we'll go to another problem. We'll have a discussion on the radius of curvature.
Sir?
Yeah.
Sir, there in the above explanation you have told that the tangent will be along Vino, sir. Here it is not along Vino, sir. Then how can we tell it as that, sir?
This one, yeah, it is there, no? A parallel.
Sir, here, sir, in the question, sir.
Here.
Yes, sir. No, sir, here.
No, that's why I resolved g sin phi. No, the g sin phi is what? Tangential acceleration.
Okay, sir. Okay, sir. Thank you, sir.